So I think it is already 11:14. So if our expert Bhaskar sir is ready, we can start the session. Sir, are we?
Yes, we are ready.
Okay, okay. Thank you, sir.
So everybody can see the screen?
Yes, sir, it is visible.
Okay, all right. So thanks again and welcome back. So I'll be going through, and I would suggest to take an advantage of a session. If you have any question even during a slide, feel free to put on a chat window. I will try to make sure that, and that is how you can take an advantage, because there may be so many things which may not have been covered, but if you ask, it may come up during the discussion. So I would suggest to make it more interactive as far as possible. Audio is a challenge, so you can always put it on a chat, and I can try to satisfy your queries to the best level I can. So today we are going to talk about, I think this is not new, as Undrajit sir was saying, the IoT is not a new term. It's my favorite phrase which I use is, it's basically a old wine in new bottle. There were connectivity in the past, there were controls in the past, but there was not so much of expansions of the internet and the speed which is available today. And because of that, things has become, very easy to connect. So if you take even the oldest communications or a interface like 4 to 20 milliampere is also has something there. Then your RFID, then machine to machine communication. Before the IoT word came, there was a machine to machine communication. And now it is becoming, internet of everywhere, internet of me. So a lot of things, a lot of buzzwords started flowing around. But essentially it is being, putting everything together. And I think I would like to stress upon, I don't know with which discipline people are here, but as in a morning session being said, this is truly a interdisciplinary, activity and a product out in the market. And so I would sincerely suggest the faculties for example, computer engineering or science and electronics, electronics and mechanical. Even I would go one step beyond to have your collaborations with maybe the Parbeco research might be going on in a pharmacy college, the bio research might be going, so on and so forth. So take advantage of that and make it as a collaborative effort to realize any product idea or even to file a patent, because all faculties are here. I would encourage that you should focus more on innovations and filing the patents for your respective colleges. So in agenda today, I'm going to go through what are the tools and technologies. Some of the case studies, as I said, that machine learning and IoT are complementary to each other. One collects the tremendous of data and one analyzes and puts something which is actionable or information. So which is the word artificial intelligence, Internet of the Thing. Which includes deep learning, audio analytics for a portable model using n resource constraint environment, ONNX, and LLVM. I'm also touching base certain things onto the embedded side, for product side, because there are a lot of things which is being done on the right side, which is on the cloud side for the machine learning. But edge computing is the current topic, and I think that is where you have to bring things to the your system. So feel free if you have any question in between during the session. So this is what IoT and ML looks like. These are the building blocks. You have IoT all put together makes your edge computing. You have a computer vision which becomes your eye. You have machine learning. You have audio analytics. You have real-time operating systems or OS. You have platforms like RISC or x86 or ARM, and you need a tools like LLVM to make your compiler smarter and compatible and a tool chains. So this is in nutshell, what edge computing means. Edge computing is nothing but your connected embedded device self-reliant to take call on their own. For example, if the car is running on the road, and if there is an object being detected, now there is a passive alert which can be generated at the same time. It can also de-accelerate your car. So that's what the action being taken. So there are many examples. You go through it, but this is in nutshell what I'm going to cover. And I know that during this session, I think many areas which is getting covered here. And I think that put together takes the complete shape of the IoT and machine learning put together. This is what you need. I mean, this is a bare minimum. That could be something more you can add. So I'll go through the machine learning frameworks. IoT frameworks is all joined, which is covered here. The machine learnings are like YOLO, SSD, SAGNet, CNN, RNN. Your compilers will need your LLVM, your platforms, which is the GPU platforms and the FPGA platforms, your ARM-based platform, x86-based platforms, and your RISC-V-based platform. RISC-V is becoming very, very popular because it is open source, and that's why I have taken it as a slide here to give an idea so that you can take home, and if you would like to do something on your own with your student, I would suggest it is a good time to get started. ONNX for the portable machine learning models, various libraries like Keras, NumPy, Pandas, Scikit, TensorFlow, Matplotlib, and OpenCV. Languages, as all of you know, that Python is right from embedded to the enterprise is #1 committed on the Git repository today, which has taken over the Java. C and C++ native always required. Go is also coming up pretty well on the embedded side. So this is what about the languages. The protocol, as all of you know, for the IoT, you have MQTT, you have SOAP, you have COAP, you have XMPP, you have DBus, the traditional HTTP and HTTPS, and RESTful APIs. Coming to the cloud side and the applications running on the Android stuff, so you need maybe AWS, you need Azure, OpenStack, MinStack, OneStack, and DevOps, which is part of the deployment. So this is end-to-end makes your tool which is required right from your sensor to your aggregator to your cloud to the various data science being run or machine learning which is run either at edge computing or being run at cloud. Any questions so far? If there, please put it on the chat. Okay, so moving to the next slide is certain practical use cases. I think there are many use cases, but certain use cases which is in implementation today is a smart retail. I think everybody might have seen the Amazon Go, right? Where you just go and grab and that's it. That's a virtual store. So a camera system equipped with computer vision capabilities can use the facial recognition to identify customer when they walk in through the door. So that's the first way things being used is identification of a customer. Then system collects customer intelligence, including their gender, product preferences, traffic flow, and more. They also predict consumer behavior and uses that information to make decisions about the store operations. That means which products to be placed where, and which products has a lot of attention. And there are two things in a retail. One is customer centric and one is seller centric. Now there are various advantages to the customer centric as well. As a customer, if you walk in, many times you roam around to find certain details for attending. But assume that you have a QR code or a barcode and you show it somewhere, and then or maybe you scan on your mobile, and all the information about the vital allergies related stuff or the health benefit or the health hazard is being presented to you. Not only that, it can also give you the competitive products available. So consumer can take a conscious decision while making purchase. That is on the consumer side. On the seller side, they can use intelligence and create their offerings, which helps in return on investment and improved customer experience. As mentioned, if system detects that majority of the customer walking into the store are millennia, then it can push out a product advertisement or in-store specials that appeal to the demographic, that by driving the sales. And smart cameras could identify shopper and allow them to skip the checkout, like what happens in Amazon Go. That means, it's like you walk into the store, you get everything, and you just get out, and your payment is being debited. So this is one of the smart retail use case which is in place. Before the Android become popular, we implemented this, and one of the complete product development, which has more than 2,500 retail stores in US, and those were the time where Android was not around, and it was basically using the Zigbee interface of your handheld device, using your camera and then connecting it to the enterprise. And they yield a lot of intelligence, and they created a lot of reshape of their stores, which resulted into the sales, the better sales, and the loyal customers. Okay. So let me go to the other IoT practical use case, which is a fleet management and autonomous vehicle. I think all of you know the autonomous vehicle. So basically it is used to fleet management today to help monitor vehicle, reduce fuel cost, track vehicle maintenance, and to identify unsafe driving behavior. This is very, very important. And a lot of things are happening. You can either prompt the driver while he is on the road, or you can have a special training session being organized based on the driver behavior when a person is on the road driving a vehicle. Through the IoT device and GPS, which has a sensor and other artificial intelligence system, and companies are able to manage their fleet better, and that is related to AIoT. And these are all deployed use cases. One of the product which we developed and delivered to the US customer from my previous organization, and it is a huge success there. And it takes the all vitals of the systems, the road, and then there is a dashboard, and it also tells you at any given point of time where the truck is. So a lot of intelligence can be created here, and a lot of machine learning can be applied. Another way IoT is used today is the autonomous vehicle, which all of you know that cars autopilot system that uses radar, sonar, and GPS and camera. Now this has to all fuse together. About driving condition, we have one presentation here on the ADAS related stuff, which is a lane detection, as well as the pothole detection and the signpost detection. And AI system can make a decision about the data the Internet of the Things devices are gathering. Delivery robots, which all of you know, is becoming, the trials have already started by Amazon, which is a drone and delivery robots. A lot of you must have seen that autonomous delivery robot has helped even in the pandemic, where person is quarantined, especially in the hospital area, where you have to deliver medicine or food. So this has come quite handy in this environment. Now, artificial intelligence or machine learning and IoT has various industries where it can be put, be it healthcare, be it transport, be it your defense. Recently, you must have heard that there was a precision attack being made on Iranian diplomats. We'll not go into politics of it, but it was a so precise attack that the person was having his wife sitting next to him while he was driving the car. he has been shot dead, nothing happened to his wife. So that was a precision being used, and it was all done by the AI modified weapons. All of us knows the surgical strike with the precision India carried out. So these are some of the examples which is in the defense, and there are a lot of things which can happen. All of you know about the fitness things and a lot of guided fitness, including your diet, how many steps you have taken, how many calories you burn, so on and so forth. There is a use case on which I read recently, is that based on your voice in a current environment of a COVID, it can quickly give you the early signs of maybe getting infected by COVID, because vocal cords get inflammation and voice changes. So there are AI things which is running, which can give you the prognosis about the things. We all know about the CT scan and all, which is being used in the healthcare environment. So these are some of the typical use cases which is there. And I don't know how much you know, but in 2017, Bill Gates has given a lecture to the all graduating student, and he said that if I have to start all over again, what 3 things I'll pick. So one of the things which he has picked up is the artificial intelligence, that he will work on artificial intelligence. The other which he did is about the clean energy, and the third was the bioscience. Now, if you put together, I think machine learning or deep learning and IoT has a potential in all these areas. And by the way, as we live in this era, we start using this, be it your virtual assistant from the bank or a website, which collects your patents and guides you. So this is becoming a daily life rather than any sci-fi or a futuristic thing. Any questions so far? I think this is all known to you, but I just taken a gist of it. There are endless examples in various industries. The energy industry has a lot of implementation. I was talking to one of the greatest company in the world today on the energy sector, because of the India, I'll not share the name. He started asking me for about artificial intelligence to be put in by collecting various information, and I asked very simple question, that sir, are you planning to replace your operator? And he said, yeah, looks like you read my mind. So there are a lot of things which is happening, which is being currently done by human being, which can be done with more precision, of course, with added supervision from the human being. Human beings are not going to get replaced. It will never get replaced. So those are the things which is happening. Industry 4.0, which has been talked about. So all these areas has a tremendous potential of deep learning and IoT. I would suggest all of you to focus here, because this is a very tiny architectures. This is an open source architecture. So it's a far smaller than other commercial instruction set architectures. It's a clean slate design. That means it has a clear separation between user and privileged ISA, and it avoids the micro architecture or technology dependent features. It is very modular. It's a small standard based ISA and multiple standard extensions, and designed for extensible and specialization. This is very, very key focus area. Many people, because we have been into industry where we cater to the semiconductor as well. So many chips are getting designed, which is self-reliant to run the artificial intelligence on its own, without the help of the cloud, which is part of course, the edge computing. There is a need of various extensions to your instruction sets. So there are various accelerators and things which you can put it as part of the system on chip. Stable, it's a very base and standard extensions are frozen, and additional via optional extension, not new versions. So I would seriously encourage all of you to have this as a part of your curriculum if possible, and also to make your hands dirty and have your student also makes their hand dirty here. Any questions so far? So this is the NDIS board. We are the partner of the NDIS, and this is this IP. This is a RISC-V IP. It's being put it into a Xilinx Arctic 7, which is having the IP running, and it has a built-in micro USB to UART bridge and powered via USB. It has NDIS core, NDIS shape platform IP support of N25 and A250. It has 3 peripheral devices, which is 4 megabyte SPI flash for user program and data, 4 LED and 4 user buttons, GPIO and pulse width modulations, and UART and I2C and SPI. So this is very not very costly like your Raspberry Pi or maybe your Arduino board. This is available, and you can make your hands dirty using this. Just for the sake of your anxiety, I'm showing one video over here where with the same board, the LED, and it uses the Arduino IDE. So it uses the Arduino IDE, and you can use that to have the programs being developed. Any questions so far on the RISC-V? Okay, so what all can be done here? You can run the free RTOS or Amazon RTOS on this. You can compile and port your all join for RISC-V architectures. You can make it cloud agnostic interface. You have ONNX model running here, and optimization of compiler for custom specific implementation using LLVMs. So this is what the road ahead for the faculties who would like to do something further. These are the areas which is open to you to work upon. Any question? Okay. So these are some of the practical use cases of machine learning. I'm going through the videos here. So this is the land detection, which is using the computer vision, and it can detect your land. And this is one of the features which is being used with various model luxury cars, and it will start becoming available into your so affordable cars in India as well. A lot of innovations are happening here, and to make it more cost effective. This is the land detection. This is the second video, which is on the pothole detection. So this can detect the pothole on the road. This is again on the machine. All these are machine learning implementation, which has been shown here. So which can put the bounding box around the pothole. So this can help you to avoid the pothole, steer, or to deaccelerate if your vehicle is an autonomous car, to avoid even hitting activating your airbags, for example, if it is a heavy pothole, too deep pothole for that matter. This is face detections and recognitions, which is again can be used, which can put the bounding box around the face. It can recognize the face, the use case which we were talking about in the retail. So it can identify and recognize the face. This is the signpost detection. So that means while you are on the road, it can detect a signpost and can give you the indication passive or active alert. If it is active, it will deaccelerate. If it is passive, you can see on the right corner, it will show you. So that is where it is detected from the, this is a street. So the speed has to be slower here. Then you are on the road where you will get different speed, and you can have the passive alert or active actions being generated using this.
Sir, there is a question from Pranali Pawar.
Yes.
She has posted, can RISC-V work as a Raspberry Pi as a small computer?
Of course, yes, by all means.
Okay. She
There
has
are a
also,
lot of, so, okay. I don't know how many of you, sorry, sir, you were saying something. I'm sorry.
no, she has also raised her hand. If she want to ask anything.
Yeah, because I am on a presentation mode, so I won't see the raise. So maybe I would request you, sir, to coordinate. And if
No,
there is
as
a
you
question,
are asking
Excuse me, sir.
yes.
Yeah, Pranali Pawar here. I just want to ask whether Arduino, if we are comparing the RISC-V to Arduino, na, so Arduino cannot be operate with the operating system. Means it have a desktop, means a DOS type system where we have to write the command. So RISC-V also has the same option, or we have to upload a operating system there.
So both things are available. As I said, that you can have the free RTOS on it, right, which you can deploy, or Amazon RTOS. That's one option which you have. And there are innovations happening, already been done, where in an open source Git repository, you can even run the Linux environment.
Okay, thank you, sir.
Okay. Before I jump, just to extend to your answer, is the beauty of RISC-V is that it is extensible. So that means you can get a board, you can make your additional instruction sets which comprises to your machine learning, or maybe any application for that matter. That's where the beauty lies. This is a human detection. This is a vehicle detection video which detects the vehicle on the road. So these are all facts and figures. So this is not something just a video. We have the data to be shared, because that is how it is a confidence building and give you also the enthusiasm to do it on your own. The vehicle detection has used the open source data set. The framework which is being used is YOLO, Darkflow, and ResNet 50. The training time, it took around 36 hours on NVIDIA board. And as you know that in machine learning, please never get discouraged when you get very low accuracy on the first instance. You may not get it. That is the time where you have to improve. So initial accuracy was 60%, which has been improved to 96% accuracy. The roadside detection, which I've shown, is the German data set. It has a 43 classes. Again, it is YOLO Darkflow. It has a 72 hours on CPU, i3, 8 GB RAM. Initial accuracy 43% and 74, and all we have modified. Face detection, it is used with the self-collected data set and use the OpenCV. Land detection is TU simple dataset, OpenCV, SegNet, and CNN. It took 12 hours with i3 CPU, 8 GB RAM. Initial accuracy is 54%, then 69 and upward. Porthole detection, open source from Electrical and Electronics Department, Stellenbosch University, YOLO, Darknet, and Darkflow. 24 hours with CPU, i3, and 8 GB RAM, 32% initial accuracy, and the final accuracy 58% and above. This is a snapshot when we have gathered. Now, at this point, it is even much more. Any question? Okay. This is one of the very important thing, audio analytics, which is becoming very, and the beauty with audio analytics is that it is not too much of data like video. And your conversational AI, right, which you are doing with your Alexa or maybe your Google Home or a Siri, is all based on this. It learns your accent, and then based on your preferences, it presents certain things. These are all machine learning use cases. Here what I've taken is gunshot detection, taken from the urban data set, from 7,467 audio files from 10 classes, and it has used the CNN framework. It took 40 hours. initial accuracy was 64, reached to the final accuracy of 92%. I don't know, because of the setting you will be able to hear the audio or not, but I'll just try to play. Can you hear, sir, or no?
No, sir, it is not audible.
So I think that this Google Meet doesn't have a provision to give the computer audio. But basically what it does is it identifies the gunshot with the other sounds which is there. For example, maybe if I put my computer sound little hard, no, I think let's leave it. So gunshot from balloon and gunshot together, it will identify siren and gunshot, it will identify gunshot. From drilling and gunshot, it will identify gunshot. Car horn, and so basically with various surrounding noise, it will identify the gunshot, and then you can take appropriate actions if needed. For example, you can dial the emergency help number, or you can dial police. You can generate an alert. Let's say it's a camera which is being mounted with a microphone on a street, and it detects the gunshot. So then it can alert the relevant agencies to take appropriate actions. There are a lot of advantages. Many a company, I'll not go by the name of the company, but one of the premier networking and data communication company based out of San Jose and having the second largest R&D center in India. They have, I think, very renowned video conferencing solution. Now that video conferencing solutions recently has come out with support that while, like me, right, I'm having the conversation and somebody hits the doorbell, obviously you will hear that doorbell. But there are, deep learning which can be applied, which will remove those noise. If I'm typing the keyboard, it will remove the keyboard sign even it is before it is being transmitted. If let's say if it is a longer duration meeting and I'm having my lunchbox and I'm crapping my lunchbox here, you will hear those crackling noise. That can also be removed. So these are some of the use cases which can be used. So conversational AI becoming very popular, and that is where the audio analytics is very, very important and vital. Relatively simpler, I would not say so simple, but relatively simpler than the video analytics to get implemented. Any question here?
Sir, there are a few questions earlier posted on the chat box.
Yes, please.
One question by Kiran Panchal. What is the difference between AI and IoT?
Okay.
Yeah, and another question was by Jawahar. Risk V. This V stands for fifth generation or some other meaning. These were the two other questions.
Okay. So, okay, let me go one by one. So AIoT is artificial. So basically when you have, okay, if your car is having the automatic gear shift, right? That is known as automatic car. But if it is a manual, it's a manual car. Similarly, when artificial intelligence or deep learning, which is being added to the IoT, because IoT collects tremendous amount of data. And again, let me remind you, let's funny, comparison, but it's like a puzzle, right? So there is a lot of things being gathered by IoT, but needs to be analyzed. And that is where analyze and actionable to be taken. That is what being done by the machine learning. What we put together is the word coined as AIoT, artificial intelligence, Internet of the Thing. Now, Internet of the Thing can be also IIoT. So that means you can even put an A in front of AIIoT. So these combinations are endless, but in nutshell, when collected data through the IoT is being analyzed at the edge or at a cloud and acted upon, that is where it forms the AIoT. Yeah, what I think the second question is the risk. Yeah, that's what the risk generation, which is being started from the Berkeley, and basically given name risk V, which is also being interchangeably being pronounced as risk I or risk V. Any other questions, sir?
No, sir. These were the questions posted earlier.
Okay. Any questions on audio analytics from anyone? Okay. Let me move further then. This is the Go language. Here I have a video which will be object detection. So it will detect the mobile phone. You can see the bounding box is that already identify person. It will identify mobile, and then it will identify the water bottle as well, as you can see from the bounding box. Now this is done with OpenCV and TensorFlow. When we use Python, it was giving 3 frames per second for the detections video. While going through the Golang, it improved the accuracy to 8 frames per second. So Golang is also becoming popular into the embedded environment to make it native. This is IoT case study. I think there are a lot of things which is there, so I will not go into the nitty-gritty of the IoT. But basically, the all-join framework, which is now Open Connectivity Forum, you can have the platform independent, language independent, cloud independent, frame. This you can extend the framework. Actually, framework has basic infrastructure, but you can extend this framework, make a interoperability and make a intra-communication. Just to give you intra-communication is creating a mesh. For example, you are watching a TV, and in your door phone, door camera, somebody standing there. Now it can create a picture-on-picture on your TV of showing the face, the person who is in front of the camera. So basically creating a mesh. On the right side, if you see about the applications layer is IP network connection, which could be Wi-Fi, which could be Bluetooth, which could be power line connections. The PLC is also becoming popular. Your Ethernet, then your physical layer, then you have all-join router, which helps you to the discovery, connection, and network management and security. On the right side, you have a Crown library, which is a leaf node, which is a standard client or a thin client. And then you have onboarding of the devices, control panel can be generated, notifications, audio and features. And on top of that, there is application layer. So this is the framework, there is a tremendous demand. Okay, so let me touch upon this area. IoT way it has been grown, it still, I would say, in a so-called fragmented market segment. So there is a need of standardization. So a lot of things are happening in these areas for standardization. To give you a simple example of the standardization, which is very easy for you to understand. Let's say I have a security and surveillance Kerala, I have a video management software running. Now every camera has a different way to communicate. So today, if I am using a Sony camera, for example, and if I would like to go to the Bosch camera tomorrow, I have to change my driver. So it is not easy. It is not a drop-in replacement. The word being coined is a drop-in replacement, because the capabilities and the way it interacts is different, which is known as a customized driver. Now, that is where their ONVF, the Open Network Video Interface standard which came. So if your camera is ONVIF compliant, you can replace from Sony to any other camera, because then your driver sitting on your video management software knows how to communicate without getting into the nitty-gritty of which SoC is being used, so on and so forth. So there is a lot of work is happening in this area, and still happening. So that is the one of the things which is a faculty which you can pick up. And other thing which is happening is the scale up is becoming always a problem. So scaling up when you have the thousands and hundreds and millions of devices, how to scale horizontal and vertical. So that is another the challenge area where people can work. and the security, of course, which has already been talked about, the prime concerns. Okay, so any question here? Okay, so meshing it up with the clouds with all join. So you can have the cloud abstraction layer, which can make it, cloud agnostic. And then a native all join is restricted to local IP, and then you can have the proximal network technology. So this is creating your mesh network using the all join. This is one of the classical sort of a known as a hello world using IoT and Alexa and conversational AI. So let me run this video.
Starting discovery. This will take up to 20 seconds. If you already, please enable the smart home skill for your smart device from the Alexa app. Alexa, bulb on. Okay. Alexa, bulb on. Okay.
Okay, so basically, as you can't hear the audio, I'll narrate it for you. So setup wise, it has a Raspberry Pi, it has a one lamp, and it has Alexa, and Alexa is being connected to desktop running the Ubuntu, and it will discover the device, and then it will give the command, it will turn bulb on and off. What is being used here is all join framework, which is being used on Raspberry Pi. It is C++, cloud connection is AWS and IPM. Hardware is Linux, Windows, and Raspberry Pi. Protocol is MQTT, HTTP, XMPP. And integration of AWS cloud, IBM cloud, and make cloud abstraction layer. So that's what has been done, to make it work with any cloud. And control device is using the Alexa, which has been done using Python and AWS, and controlling bulb by using the Foxmo library. So this is where it can discover the device, it can register the device, and you can have the conversational to put your bulb on and off. I'm sure the people will take a lot of IoT use cases, but this is being considered as hello world of IoT. So I just thought, because we are all talking about IoT, to showcase to you. Any question so far? Okay.
Yes, sir. One question from Pranali.
Yes.
AWS come under which style of IoT?
AWS is Amazon Web Service actually. So it basically cloud, right? It puts under cloud. So that is on the right side of the. So when you work, your machine learning can be doing at the edge computing or on the cloud. So when you do it on the cloud, that is where AWS is there. There is also, I think it's a good question. There is a word which is being coined as a digital twins. I don't know how many of you are familiar of the digital twins. Digital twins is, let me take the example of this bulb, right? Now bulb could be on or off. Now from your dashboard, if you would like to know the status of the bulb, you will have the object bulb available on the cloud, and it will have its status. If it is on, it will show on without having the round trip being generated right to the board. And if somebody says that put on, it will not do anything because it's already on. If somebody said put off from the other application or somewhere else, it will go and make it off. So when you talk about the digital twins, you have the entire factory as a digital twins. So that is where your Amazon Web Services and cloud comes handy, where your digital twins environment is running. Hope that answers the questions. If further doubt, please feel free to ask.
Pranali, Yes, yes, go on.
So actually, I want to ask, like, if we are taking AWS, na, so which style it comes under? Means IoT, AI, or AI IoT, or II IoT?
Okay. So first and foremost, when you use AWS, right, there will be a certain application you have in mind. Now, I'll try to make it your life little simpler. Let's say you use. Let me take a case of your traditional home environment. Your refrigerator and oven is, let's say, intelligent enough, and you would like to, let's say, this is one of the use case where in your refrigerator, the daily milk usage is going below the required level for your daily need. It will generate an alert to you. Now that going to cloud and coming to your you are sitting in your office and getting your notification that the milk level in your fridge has gone down. That is classical IoT, because no action has been taken. But because fridge is intelligent, it has already pushed the notification to the cloud as an intelligent device. But if you know your supplier, let's say I'm just taking it may become a reality. Your supplier may be Big Basket Daily or Amul, you can place an order. So then it will automatically will place an order, and without your knowledge, the replenishment will be delivered to your doorstep. That is where it completes the IoT. Does that help to understand?
Yes, sir. So
Okay.
one more is there.
Yeah,
When
sure.
we are talking about virtual and this thing, digital twins, these are same like big lamp designed by Adrian, means where one lamp has to be means the main parent lamp when get glows, the other lamps of each in the world wherever it is, it may go glow.
No. That's totally different.
Yeah.
It's totally different. This is basically without going to round trip, because let's say you would like to look the status of because what happens is that there are hundreds and thousands of the devices, right, which is being connected. Now every time if you have to go to the device to find a status, right, it's a lot of traffic, which you can avoid to have the traffic only on the status change. Are you getting my point?
Yes, sir. But one more example.
So okay. One more example is let's say you digital twin. I'm just going to the digital twins in that area. Is, let's say you have a let me go to the again refrigerator case, right? Your fridge. Now, if that fridge has a capability to show, has an inside camera and show all the shelf, right? And then those shelf, let's say I have 3 apple in my fruit shelf there, and I took out 1. Okay. Now you are sitting in the office. Somebody has consumed apple at home. How will you come to know? So that will give you the notification, because the freeze has been opened, the one has been removed. That will give you a notification, and when you go to find out, it will automatically place you without going to the fridge. So anything and everything which is available as a capabilities which is being stored onto the cloud is known as a digital twins. The entire factories are digital twins nowadays. That means your how many boilers, what are their pressures to at this point of time, the whole factories. There is a video of there. I think I don't remember which company, but there is a video which talks about the entire factory digital twins. Go into the Google and figure out the digital twins factory. You will figure out. Okay.
Thank you, sir. Okay.
Any further question?
Yes, sir. There is one question from Abhijit Gole. I request and
so what's the question? What's the question?
Yeah, like ISO OSI protocol model, is there any attempt being done in the field of IoT to standardize the communication to making sensors and devices communicate without hurdle of native language drivers?
There is a lot of innovations happening. Protocol standardization has already happened, as you know. So there are a lot of things which is happening in this area, and there is tremendous scope as well.
Yes, sir.
Yes. Any other question?
No further questions, sir.
Okay, thank you. So when you work, what are the challenges which you face? So challenges when you work with IoT, the security is one of these, which everybody knows. Interoperability, ubiquitous connectivity, evolving architectures and competing standard. Again, it talks about what we just discussed, and complexity in the integrations. So these are some of the challenges on the IoT front. When you go to the machine learning or audio analytics, what are the challenges? Auto annotation, because you have to train system, right? Now training the system, you need to do the annotation. Auto annotation is one of the big challenge, because it requires a lot of manual efforts to do that. There are things which you can do semi-automatic. So that's one challenge. Time for training the data set. Iteratively pre-processing the data. Now, as I said that, when you start your machine learning project, maybe you may get 40%, 50%, depends. And when you you may end up with 90+%, accuracy. So interactively pre-processing the data, improving the accuracy, and finding relevant data set. Now, this is one of the things, as you know, that data is the new, gold, as all of us, So finding relevant data set is something, very, very prominent. And I don't know how many of you know, but many of the things we feel it as a free, and we start using it, which are available from all big biz, but they actually use this data set. You are actually their collector of a data set. And they use those data set to train those systems. I will not go by, because I don't want to name any, but any three platforms which you are using today, they all do this without going by names. Hope that helps to understand. Okay, any question here?
No question, sir. You can proceed, sir.
So this is the classical case of NVIDIA Jetson for edge AI implementation, where you have the 4K video which gets decoded, and detector classifiers and trackers. And so there is a train, optimize, and deploy, which can be deployed on the drone, on a robot, and things like that. So this is, now NVIDIA is GPU based. So, and I have a slide where the new paradigm shift which is happening, we'll cover that. But GPUs and FPGAs plays very, very important role into the machine learning area. So here, by using the Jetson Nano, your single shot detection, the throughput can be improved to 20 frames per second. So this is the realistic, data which is being used. So by using the single shot, it has improved to 20 frames per second, custom model. ONNX, this is very, very important. ONNX makes your model portable across various platforms, and I would encourage to explore further. It is not intended to give the complete details on this, but this is very powerful, especially for the edge computing and the resource constraint environment. So as you know, the containers which is becoming popular into the cloud environment, similarly ONX is becoming very popular on the machine learning models running on the embedded devices. So this is the complete flow of the ONNX architectures, which has an intermediate representation, graph optimization, graph partitionings, executors, so on and so forth. Video-based edge computation, which is being done using ONNX, we could improve the performance using ONNX and PRT ResNet 18 The processing time has been reduced from 290 millisecond to 52 millisecond. That means it has improved the performance by 82%. And these are all realistic figures. Tiny YOLO V3 with ONNX has bumped up the performance by 72.3%. Reducing the processing time from 224 millisecond to 62 millisecond, which is basically 4.4 frame per second to 16 frame per second. These are the realistic data which is ResNet and with ONNX, which I'm showing here. Then Tino YOLO V3 again. So audio analytics with Jetson has improved the performance by 64%. So what it does is that it loads the Keras model, converts Keras model to TensorFlow, convert the frozen model to .tb, convert to TRT model, and inferences using the TRT model. So these are all things which is being done, and processing time of an audio file of 5 seconds, which is being done here. So this is related to audio analytics using the edge computing or GPUs. So on audio analytics on Jetson Nano, the performance improvement. So you can see the gunshot detection has also been taken over. We have done it to the Jetson Nano. This is also again Jetson Nano is very economical board to buy. I think it is below $10,000 or maybe around $10,000, and can be used to. And I would say it is good to have in your lab. I'm also touching on the LLVM because I'm trying to give you the holistic view of what is to be used in the whole environment. So LLVM is basically is an intermediary which can be C, C++, and Python, and there is a front end and a back end, and the platforms are supported Intel, ARM, and MIPS, etc. So this is where you can do the lot of optimization using LLVM. Okay, so now I'm on a slide which is basically industry trend. But before I walk through this slide, I would open if anybody has questions on things which is being presented so far. Because we have 20 minutes left, we can have the 10 to 15 minutes of question answer session.
Participant can unmute themselves and can have interaction with the expert. Or else they can also put their queries on the chat box.
Yeah, I can probably now, let me see if I can see the chat because I was just showing this only. So maybe I can see the chat. Yes. You can raise your hand and ask the question. You can put it in the chat, whatever. And feel free to ask the question. No question is a silly question, and so don't worry about it. No question? Okay. Let me go to the last slide, which is FPGAs are and SoCs targeted to run faster ML and MI applications. So that's what is happening. If you see the trend, GPU and CPU company, I'm not going by name again because I don't want to be a controversial. So I'm just using the pointers here, those who know. So GPUs and CPUs companies getting merger and acquisitions. FPGA and CPU companies are getting mergers and acquisitions. So this is getting together. So this is generating AI targeted system on chip for edge computing. It could be your wearable, it could be your smart gadget. Everywhere the edge computing is happening, and that is where the wedding of FPGA or GPU and CPUs are happening. This is a current trend. You must have seen the 2 acquisitions has happened in recent, I think, last 6 months, which is between the GPU and CPU company and FPGA and CPU company. to give them a leading edge into the era. Inclusion of different engine with CPU code to complement the AI functionality. This is again, as I said, you can use the RISC-V and start making your accelerators. Cloud accommodating FPGA to run custom models and algorithms. This is something many of the people who might be, there is an Amazon machine interface, which is known as AMI, instance running. That means you can have your algorithms being tested on your FPGA board, and then you can deploy that algorithm onto the cloud on a AWS. AWS and Xilinx has a tie-up. Again, I have to go by name because they have the tie-up, and that is where you can run those things on the cloud. This is the reality today. In a networking, it is becoming very, very popular to have the content-based networking at switch and router level. That's what is happening. Other thing which is happening is satellite-based IoT for difficult terrain and defense use, because everywhere you don't have the GPRS connectivity. So it is of course satellite IoT is not too prominent or in India for at least general public, except the space application centers and all. But in other countries, that's the reality. So satellite-based IoT for difficult terrain and defense use, and adaptation of 5G and Wi-Fi 6, complementing the growth of the edge computing, growth for the edge computing. These are some of the industry trend which is happening today. So that was my last slide to let you know. Anybody has any doubt or a question? Some of the things of this I'll be sharing with Goradia sir. They can distribute you in a PDF form. So that we will do. But anybody have any questions so far? Not related to these, even related to anything else, feel free. I'll stop the presentation.
Yes, Pranali, you can ask question.
So I want to ask, if means we are we have done with the practicals of IoT. So we have done many of the things with respect to Raspberry Pi. So when we are talking about RISC-V, so is it working in the same manner? Means you have told me that the interface will be the same, but it will work as the same manner as the practical works.
Okay, I can definitely answer your question to make it interactive. Sorry, I'm not a classroom professor, but just to make it interactive and little adding spice, I would like to encourage from the audience to answer this question. Anybody from the audience would like to attempt to answer this question? Please unmute and answer the question. To the best of your abilities, I'll definitely validate.
I would like to answer these questions.
Sure.
Actually, Raspberry Pi, whenever we use, it doesn't have a much computational power. So particularly if you want to combine IoT and after getting the data, if you want to apply machine learning algorithm on that or kind of a deep learning algorithm on that, I think whatever the board you have shown, Jetson Nano board, I think it is very much much better. It performing much better than the Raspberry Pi. So Jetson Nano board is recommended over the Raspberry Pi. If you want to just read the sensors and just you want to broadcast your data to the cloud, then Raspberry Pi is okay. But it doesn't have a much computational power, and moreover, you cannot run the Raspberry Pi 24/7 because otherwise, a lot of heat it will generate. And it's not useful for, it's okay for the prototype development, but not useful for the applications actually.
Thank you, sir.
Anybody else? Sir, I think you rightly added this, but I think her question was slightly different. Her question was that, thank you, sir, by the way. So her question was that, can I replace what I do with Raspberry Pi? Can I do with RISC-V? Answer is yes. Okay. Now, coming to the point which sir has said is about, the computational power. He is absolutely right. But there are things which is happening, and that is where the RISC-V, where you can put your model, where you can customize, and that is where it is becoming popular. As you know that I'll again not go by because that will put me in a disputed mode. But there are various system on chip which is available, which are a lot of accelerator which is available. Maybe for a audio, for a speech, for a video, so on and so forth. So similarly, if you go to RISC-V, yes, the answer is that you can have certain things which is optimized to your requirement. And only reason is to add to it is that you don't have the Raspberry Pi, which is an ARM architecture, is extensible, while RISC-V is extensible. So you can extend, even you can have the FPGA and you can extend your instruction set and visualize or materialize what you want to achieve. So that's the answer to your question. So it is not only the replacement, it is beyond that, to sum up. Any other question?
Audience, participant, any other questions from your side?
If you have question, how do I set up my lab in my college, or what project should I start, or what bare minimum infrastructure I need? I mean, anything. I'm just throwing the giving you the hint.
I request, sir, you may please brief about the basic infrastructure. You have already highlighted the same in the first slide, but still, if you can.
Yeah. Okay. Good. So basically, as I said, I would suggest if somebody would like to note it down, you can note it down. Anything like Raspberry Pi or a RISC-V board, it's must to have, I would say. Then you should have Jetson Nano or any NVIDIA or any compatible GPU board, because I'm not marketing for any specific GPU here. FPGA, because FPGAs are much faster, access time is lesser compared to GPUs. So they perform better when it comes to the AI stuff. And that is why it is becoming more popular also. Then you need, because even if you don't want to, spend on any cloud infrastructure, I would encourage to have your tie-up with computer science, computer engineer, or IT branches, and create a private cloud using the OpenStack. So OpenStack is a private cloud which you can generate in your college, and then you can run various instances into that. So basically, you need, of course, you need the Python and the algorithm and data set. So you may have to download or create on your own. So this is the bare minimum infrastructure, I would say. If you would like to do some audio analytic stuff, you may need some audio related data, or you may have to gather those data. Coming to your machine learning, I would suggest, if anybody is interested, what you can do is, because performance assessment and the trend is really a concern for student as well as for the faculties. If you can put all your data and learn, you define a machine learning algorithm out of it, which can give you the trending that whether your this year batch is going above or below the bar, and how collectively year on year you are raising the bars. So that could be in terms of the assessment. You have to, of course, punch in a lot of data, which is not difficult nowadays, because you do a lot of things for your accreditation. You can use those things for the assessment and the improvisation. So that's the bare minimum. You don't need to even, you don't need to.
Sir, this Go platform which you have suggested, along with the YOLO and other platform, is this also freeware, free source?
Yes, those are free.
Okay. So naturally, it is a new term for many of us, so we will explore it.
YOLO is basically, it's a full form of you only look once.
No, YOLO is known to us, but Go platform which you have suggested is relatively new for many of us.
So Go is actually Golang. Like, a lot of people might be knowing that in in a scripting environment in embedded, Lua scripting is also popular. I don't know how many of you might have used. So though it is not very popular, but Lua has its predominant presence into the industry even today.
Okay, thank you very much, sir, for your enlightened speech about highlighting AI and IoT together and exploring the new dimension, and almost all the dimensions are covered very well. So on behalf of the organizing team, I, Dr. Bhargav Goradia, really thank from the center of my heart, and we certainly look out to whatever new dimension that you have highlighted during the session. And naturally, the session will certainly give insight to all the participants to go forward in this direction of IoT along with the machine learning. Thank you very much, sir.
Thank you, and thank you for the being so nice audience, and wish all of you happy learning, and let's have the next generation engineers are self-reliant. I would suggest that you focus more on they being the self-reliant rather than looking that, you know, whether they become employable or not, whether they employ other or not. Let them make so reliant that they can, you know, because this is a startup era, you know, and nothing is impossible.
Yes,
And
sir.
BVM is in the right direction. You have your supercomputer currently being delivered. You have antenna for FCC and all. I think you are at the right juncture, I would say. And if you can collaborate with you know, other disciplines, as I mentioned before, in bioscience, healthcare, a lot of things can be done. So thank you again for giving me this opportunity. It's an honor for me, and it's really a pleasure to be with all of you. Have a great day ahead. Bye.
Thank you very much, sir. Thank you.
Thank you. Bye.
All the participants, we will assemble again at 1:30 for the next session. It is mandatory, as mentioned earlier, that attendance is recorded in each session. The link is shared with you in the chat box. The next session will be a session which is going to introduce about the fundamentals of IoT, covering the basics of IoT, and various concepts, various protocol will be highlighted. So that will be a basics for all the discipline. People will be able to understand it very right from the basics. So we will assemble at 1:30. The link for the same is also shared in the schedule. So there are different links for different sessions.